So let's talk about project one, in case there are some questions that we need to answer. So the goal of project one is to read a file that contains information for the matrix. The information is given like this, where it's symmetric, meaning that whatever is on the upper side of the diagonal is going to be on the lower side of the diagonal. For instance, if you look at position 1, 2, which is row 1, column 2, is the same as row 2, column 1. So this position is the same as that. This position is the same as this. You have a 0 in position 1, 4. You have a position and you have a 0 in position 4, 1. So in this case, the matrix shows that it has 4 columns and 4 rows. This shows that this matrix is square, meaning the same number of rows as the number of columns, 4 by 4. And yes, it is symmetric. And we mentioned that the band is 4. Therefore, all you need to do is read this number and keep it as int. And for this particular case, you just need to know that the band means that it has numbers throughout all the columns and the rows. In other words, for this particular case, you don't have to worry about the band. It's there because this is the type of file that we're using. Later, you can use that information for other stuff, but right now the band is not necessary. Now, what is necessary is for you to read this portion of the matrix. So for instance, what this means is that row 1, which row 1 is horizontal, rows are horizontal, columns are vertical. So row 1, which is 4, -1, -1, and 0, is this right here. This says that in row 1, there are 3 non-zero values. At column 1, you have a 4. Column 2, you have a -1. And column 3, you have a -1. There's nothing at 4, column 4, therefore you leave a 0. So a good idea is to initialize a matrix with the dimension and initialize the matrix with zeros. Therefore, when you come back to the rows and you don't see a column, then you'll have to leave a 0. Now, on column 2, or sorry, in row 2, you have that in column 2, you have a -1. So far, this will be a 0. At this point, this is a 0. And later you can say, okay, symmetric, so write here a -1. So you can do it however you want, because this is going to give you only the upper side of the diagonal, and then the symmetry is going to write the lower side of the diagonal. In row 2, you have a -1 in position in column 2. So row 2, column 2, -1. And 3, you have a 0. So row 2, column 3, you have a 0. And row 2, column 4, you have a 2.2. Now, row 3, you have in column 3, you have -1. In column 4, you have a 2.2. And in row 4, column 4, you have a -1. Now, it's symmetric, so everything that has, in this particular case, you have row 1, column 2. Now you write the same thing in column 2, row 1, and so on and so forth. So let's look at the example. The example right here, I'm going to compile my program, and then I'm going to execute it, and then it's asking for the matrix for the file. So matrix4, mat4.txt. So this first part is what you need to do. Don't worry right now about the second part. This is project 2, which is not what you need to do right now. Right now, we're going to read the matrix. So this is exactly the same as this. Notice that when you read your matrix, you have a -4, a -1, a -1, a 0, and all the way to a -1 at the 4 by 4 position. If you were to run that with 44 by 44 matrix, which is the other file that I provided, notice that you have all this information right here. In this particular case, it's hard to see because it's 44 by 44, and you have a bunch of zeros because there's only a few of them that will, as we've mentioned, there's only a few of them that are non-zeros. But when you look at the code, you need to either type the file name on your script or ask the user for the matrix, the name of the matrix. And in this case, the input is going to be called matrix, which is a string. And I have a function called read matrix, which is defined down here. My read matrix function is right here, and is a function where I have the matrix, and I go line by line reading the name. So for instance, if the file, let's run it again, if the file is not correct, mat.txt, that doesn't exist. So it's going to show me error opening the file, which is this line and we saw before. If it's successfully, if it can open the file successfully, is going to read the first line dimensions, and is going to say, basically is going to save dimension in my int n. So what we need to do is get the string called dimensions and take it to int. Notice that n is going to be my int. Okay, so when you read your next line, which we said to read each line, we're going to do, then when we read the value of each line, we are going to go, and matrix is the name of my file. Remember that when I call my matrix file, I said I'm going to name the input mat4.txt is going to be called matrix, right? Matrix is my string, and then I input matrix to my function read matrix. Read matrix is going to return a matrix, an array, and this is the array that you need to provide with your project one solutions. So the only thing you need to do is read the matrix and provide the array. You don't even have to create the function if you don't need to. All you need to do is read the matrix. So as we said before, the read matrix file is pretty much what you need to do, which is, in my case, going to return an array or a vector of vectors type double. So at the very end, you're going to have a return A. I'm closing my file, and I'm writing my matrix to the console, to screen, and I am reading my file. So matrix file one, which is how I decided to call my name when I input my matrix string. If stream, remember, this is how I'm calling my file. So every single time I call my if string, I'm going to be reading a line. So this is how I'm reading my matrix for J string. This is another string that I'm going to be reading from my file. And this is a string. And you can name your variables however you want. We saw different ways to read the file. All you need to do is go line by line and read the file, save the the number that you read, which is a string, an important step is to create an int from your string. The int is going to be saved in your columns, in your array, on your matrix. And since symmetry is 1, all I need to do is rewrite the values of the upper diagonal and the lower diagonal. So to conclude, you need to read this file where the numbers of the upper diagonal are given like so. And once you have the upper diagonal, you just rewrite the matrix and save the lower diagonal because it's symmetric.